Okay, so hello everyone, I'm Nitin here, and today we will learn basic data structures, how to implement them. For example, stack, queues. For today, stack and queues only, and we will see how to code them out using Scratch in Python. So we will use our previous knowledge of class, and we will use class to go ahead. Okay. So yeah, so we can start. So we can start first. So first, let us start with this thing that know what is stack. So what is stack? Do you have any idea what is stack? So it's a last in first out data structure. So you have an array where you put something on the top and you put things on top of one another, and at one point in time you can only access the top element. You can put on the top element and you can get from the top element. It's a very simple data structure stack, but it's extremely useful, and a lot of things is implemented using stack. Okay, so yeah, so let's see how we can go with the stack. Okay, so first of all, think of this. Stack can be thought of something like this. So suppose we have an array here. Okay, and suppose we added an item 1. So 1 is here added, right? Then we added 3 is added. Then we added 2 is added. 2 is added, right? 1 3 2. And so right now our top item is 2. This is the top item, right? Can you see that? Yeah. So this is the top item, this is 2, and if we have to pop out, then we can only pop out this 2. So how stack goes, it's something like this. Is we insert something at the top, and then we pop out something from the top, right? So there are elements before 2 as well, for example 3 and 1, but we can't see them. I mean, we don't know what is there, right? We only knows, okay, there is a 2, but there are other items as well, but we can see them what is there, but we can only access the top element. So you can stack, think of like so many things in the life. For example, stack of plates, right? If we see stack of plates, there are so many plates there, we can count them, but we can only access the top plate at the point in time, right? So okay, so let's implement it in Python. We got the idea here, right? This is how stack works. So if we have to implement them in Python, then okay. So what the very first thing is, we can make a class and name it stack. Okay, so this take what? Oh, that's why I thought. I'm sorry. Class stack. Okay. So init function. How can we start? We can start with an empty list. So let's say if user gives a list, it's fine, otherwise fine. And we can set a maximum memory for the stack. Let's say for now, for the sake of implementation, we can set let's say max or just size size of this array, this stack is 10, let's say. So okay, one more thing I wanted to see here from the implementation point of view. Let's see, suppose we have to implement this array. So suppose we using array, then we have this array here. Sorry, this is something. So remove this thing. Yeah, and so we can see this particular stack that we drawn above can be seen something like this. This is an array. We added element 1, we can element 3, we can add element 2, and the new element will be added here, and we can pop out element from here, right? This is a simple array 1, 3, 2. Is it making sense? Okay, fine. So we can make an array, we can push 1, then we can push 3, then we can push 2, and we can push as many items we want until the limit is reached, and at the same time we can pop from the top elements, right? So how can we do this? So we can make a list, self dot list is equal to list and self dot size is equal to size, right? Now what are the main two functions that this stack should support? The first function it should support is push, that we can push an element in this, push item, and second is pop item by checking constraint. What is the constraint we are checking when we are pushing the item? Yeah, if the stack is full, we cannot push, and if the stack is empty, we cannot pop, right? Okay, so def push with an element item. So for pushing first, we will check the constraint. So if the length of the array has reached the maximum size, then we can say okay, we can raise an error saying that stack limit reached, and if this is not the case, then we can simply in the list we can append the item. Is it making sense for you? Self dot list, if everything is fine, then we can append the item. Same for pop, we can make a function which will check what? If len of list equal to 0. If it is equal to 0, which means that the list is stack is empty, and we can say that raise let's say index error saying that stack is empty, and if this is not the case, then pop out the top element. So we can use self dot list dot pop, and the very last element is present in -1, and we can at the same time return it as well. Suppose sometimes we want the popped element, so we can return it as well. Okay, so push and pop is done. Sometimes we want to get the very top element of the stack. How can we get the top element? Can you let me know? Can you tell me the syntax for this? So see this. No, we have to get the top element. So where is the top element? Top element is this. If we are seeing it as a Python list, this is the top element. Hello. Yeah. So we don't know how many elements are there in the stack. We just want to get the last element, the very top element. So how can we get that? Yeah. This. Yeah, we can do that. We can do that. But there is an alternate solution for this. We can simply return self dot list dot self dot list the last element -1. Do you know what -1 does? Yeah. So okay. Another thing is to check whether the stack is empty or not. Another thing is to check whether the stack is empty or not. How to check whether the stack is empty or not? So when the stack will be empty? Sorry. No, no, no. So the stack will be empty when all the elements are done. So stack will look something like this. This is an empty stack. Nothing is there. There is no element. Right. This is an empty stack. Right. So we can simply write if len of self dot list equal to 0, then it's empty. If it is equal to 0, then return true. If it is not equal to 0, return false. Right? Making sense? So let's now create an object. St is equal to, let's create a stack. It's an empty stack for now. Okay, one more thing I wanted to check. Okay, there is a syntax error. I saw it, luckily. And there is one more error here. It's not size, it's self dot size. Yeah. Can you explain me this particular line, def init from here to here? What's happening? Mm-hmm. 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 Hmm. Okay, so my question is, if I write st is equal to stack, will this initialize an stack? Will this initialize a stack, or will it give an error? Why? Yes, we are not passing any argument, but it will not give an error because it is the default argument is passed here already. List is equal to empty. So if nothing is passed, then an empty stack will be initialized with a maximum size 10. Otherwise, suppose if you want to initialize the stack itself with, let's say, two values 2 and 3, that list is equal to 2 and 3, and we can say that okay, our stack can hold, let's say, 15 element. So even this is fine. Yeah, if you just want to initialize with the list, that okay, the stack has already element 2 and 3, where 3 at the top. Right, 3 at the top. We inserted 2 before, then we inserted 3. So this is also fine. So okay, let's for now start an empty list, an empty stack, and let's push some elements. So let's say we pushed, let's say, 10. Then we push, let's say 20, right? Okay, this is last definition. Just tell me. That day I taught that how to create a object representation. So if I call print of an object, so right now if I write print of st, it will give an error. Not error, but it won't print anything, right? Suppose if I'm printing st and I want to print what are the elements in the stack. How to define it in the class? Okay, so this is the str function, and we have to return some string, and that string, basically we have to return all the elements of the array of the stack, but in a string format, because str requires something to return in the string format. So we can write dot join, okay, and then all the elements in the string format. So we are using list comprehension here. From the list. So see what this will return. This will return 10, 20, which is fine, but this is not how the stack looks like. The stack looks like that 20 is in the top and the 10 is in the down. 10 is trailing. So we need to reverse this. So let's reverse it. So let's see how our stack looks like. Let's run this. So Python, see, this is how the stack looks like, 20 and 10, where 20 is at the top, right? So okay, now let's pop an element. So from the stack we want to pop, then we can pop, and let's see how the stack looks like. So what should be the answer for this if we are popping an element? Oh no, there were two elements, 10 and 20. We can only pop from the top. So we popped 20, so this is only 10. No, we are not printing the popped element, we are printing the stack now. So see, we pushed 10, we pushed 20, and now we are popping. So which element is left? Yeah, so let's run it. It's only 10. Okay, can we check whether the stack is empty or not? Print. So st dot is empty. So is the stack empty? Okay, so what should it return? False. False. Yeah. We can also check what is in the top of this. So what it should print? There is only one element. So it should return 10. Right. We can also add some element. We can see. Let's after popping it out, let's push some more element. Let's say 30 and 40. See, the top is 40. Right. Okay, so yeah, this is how stack is. So this is the very lame version how stack is implemented internally. They also put so many kind of checks, and there are other functions to implement for the stack. But this is how we can implement stack initially. So this concept is good to know if someone asks you to implement your own stack and you know how stack works now. Okay, so yeah, this was for today's class. We learned stack. As an exercise, I give you to implement queue. So you implement queue. If you're getting any problem, then refer this video. And a queue is nothing but a first in first out. Who inserts first comes out first. You can use the same approach of using list here. Just one thing you have to take care, how to push and how to pop, and otherwise everything is fine. So this I leave as a task to implement queue, and in the next class I will give you the solution how to implement a queue, and then we can learn something new over there. Okay, so this is for today. See you then. Bye bye.